Alright, so in this video we're looking at limits, right? So for limits, basically we have basically four main aspects. So we have the limit by substitution, which is the very basic one. This one, you just substitute the value of x you are being given. Then we have um, limit by factorization. Then we have limit by L or Peter's rule. Then we have limits to infinity, but we'll not cover that in this video. There will be a separate video for limit to infinity. Then we have limits to infinity. But let's look at these 5 questions very quickly. So for question 1, we have limit x to 1. We have 2x plus 5. So this one will be using limits by substitution, because you can see from the question it is a very basic question, right? So when you see basic questions like this, then you're using limits by substitution. Basically, when we get to where we need to use limit by factorization or limit by L of Peter's rule, I will explain what you need to look out for to know that okay, this is what you're supposed to use. But for basic questions like this, you are using limit by substitution. What is limit by substitution? So now let's say, for instance, now you have 5 raised to the power of x, right, is equal to y. And now when x is they're telling you that x is equal to 2. Now to find y, you just have to substitute the value of x here to get the value of y. So that means y will be equal to 5 into the bracket of 2, because 2 is representing x. So you substituted 2 for the value of x because 2 is x, right? So y is equal to 10. So this is basically what limit by substitution mean. So here now we are going to just have, since x is 1, we're just going to put 2 into the bracket of 1 plus 5. Then we have 2 plus 5, and this is equal to 7. Very simple. So now for question 2 as well, we have limit x to minus 1. So this question is also a very basic question. We just have x plus 3 over x minus 2, right? So it is basic. So what we do here is still limit by substitution. So right here we're going to have minus 1, because minus 1 is representing x. We have plus 3 over minus 1. Okay, so that is supposed to be minus 2, not plus. So we have minus 2, and this is equal to minus 1 plus 3 over minus 1 minus 2. So this will be 2 over minus 3, right? 2 over minus 3, and this for question 1 and 2. Then we'll move to question 3, right? Question 3, move to question 3. So for question 3 here, we have limit x to 2, and then we have x squared minus 4 everything over x minus 2. So now this one is not just basic, right? Because here we are having x squared, right? So it is not as basic as number 2 and number 1. So for this question now, we cannot just go ahead and substitute our values into it, right? Because it's not just basic. For this kind of question, we are going to factorize. So here we'll be using limit by factorization, right? We can also use L or Peter's rule for this, but let's deal with limit by factorization for these 3 questions, 3, 4, and 5, because they are not looking basic, right? Then we'll also use L or Peter's rule for it. The idea is that you're supposed to get the same answer whichever method you use, but L or Peter's rule has some specific conditions that must be met before you can use those rules. But let's go with limit by factorization first. So for this one now, we have x minus 4. So we have to factorize x minus 4. So x minus 4 basically is x plus 2 and x minus 2, right? When you do difference of two squares, because if you take x plus 2 and x minus 2 and you multiply them out, you're supposed to get x squared minus 4. That's the idea. So this one multiplies this, it multiplies this, then this one multiplies this, multiplies this. So x times x will give you x squared, x times minus 2 give us minus 2x, 2 times x will give us plus 2x, 2 times 2 will give us minus 4. So this one here will cancel out each other, right? So we have x squared minus 4, and that is the same thing that we have here, right? So it means that this is the correct expansion for this, right? So here we have x minus 2 under the bracket. So now from here we can cancel out x minus 2, because we have x minus 2 up and down, so we can cancel them out. So now what do we have left? We have x plus 2. Now does this look basic or not? It does. So because it looks basic now, we can just go ahead and do limit by substitution. So x is 2, right? So this is going to be 2 plus 2, and this gives us 4. Very, very simple stuff. You just need to know that once it's not basic like this, you are using limit by substitution or use L'Hopital's rule. When we get to L'Hopital's rule, you know where and where to apply them. Okay, so for question 4 now, for question 4, we have limit x to 3, and then we have x squared minus 9 over x minus 3. So very quickly, this one, when we are factorizing, it's going to be x minus 3 and x plus 3 over x minus 3. Alright, so now before we go ahead, let me just say do something quickly. So now for this one where we have x squared minus 9, right, you can do something like this. You can say x squared minus 9 is equal to 0. Then you bring this 9 to the other side. So you have x squared is equal to 9, right? That's plus 9 now. So you take the square root of both sides, right? And this is going to be equal to this square. So you have 9. Whenever you have square root, you're adding plus or minus, right? So this is going to be x is equal to plus or minus 3. So basically you are saying that x is equal to plus 3 or x is equal to minus 3. So now very quickly, you're going to now bring this form as if you are turning it back to a quadratic equation. And if you are doing that, whenever you have something like this, x equals to plus 3 or x equal to minus 3, this one will come here. So you're having something like this, x minus 3 is equal to 0, or here you're having x plus 3 is equal to 0. Now because you want to make it a quadratic equation, you're going to now say that x minus 3 multiplied by x plus 3 is equal to 0, right? So this part here is what we are taking and we are using here, right? So if I mention you don't know how we are getting all these values or it's looking like magic, you can just do something like this and you get it. If you try it for the x squared minus 4, you still get the same thing, right? You still get the same thing. So very quickly, when we have x squared minus 4 equal to 0, x squared is equal to 4. So this will be x equals to plus or minus 2, right? Because you're taking square root of both sides. Then you see that you still have x minus 2 and x plus 2, and then you plug it in and then you solve. So something very simple, just a very neat trick that you can try. You have x squared minus 16, you can try it for things like that and it should work. And it should work, right? So here you're having x minus 3 and here you're having x plus 3, and then you have x minus 3 under. So this will cancel this. So here you're having a very basic form. So x is limited to 3. So you have x plus 3 up. So here we just substitute 3. So 3 plus 3 and this is equal to 6. So you can see there's nothing really hard with when you are doing limits. You just need to have some basic idea or some basic things and then you're good to go. So for question 5 now, question 5 says we should limit x to minus 1 to negative 1. Here we have x squared minus 2x plus 1 all over x plus 1. So now here we're going to factorize the up because it's not just basic, right? So can we factorize the up? Let's see. So x squared minus 2x plus 1. So now when you are factorizing now, because this is a quadratic equation, right? When you are factorizing, what do? You say that you multiply the coefficient of x squared, which in this case is 1. You multiply it by the constant, which is c. 1 times 1, that's c. That's 1, Abi. Then this one that is in the middle is minus 2. So here you're going to look for two numbers that when you add, they give you minus 2. And when you multiply them, they give you 1. Right? And what are those two numbers? We have minus 1 and minus 1. Minus 1, because we're adding down, right? So we'll put plus here, then we'll put minus 1. So this minus will multiply this plus. So we have minus 1, and this is minus 2. So that means for this condition, it checks out. But what of minus 1 times minus 1, right? Because this place is telling us that when you multiply them, they must give you 1. Minus times minus will be plus, then 1. So that means it checks out. That means minus 1 and minus 1 are correct, right? So since they are both correct, we're going to plug it in. We're going to plug it in into this. So plugging it in now, we are going to have x squared. So we're going to have x squared. So now we're going to replace this minus 2x, right, with those two values, minus 1 and minus 1. But we're not just going to put minus 1, minus 1. We're going to add x, right? We're going to add x. So we're going to be having x squared minus x plus 1, right? This minus x will still give us minus 2x. So basically, we have not done anything. We just wanted it to be 4. We wanted to have 4, 1, 2, 3, 4, so that when we factorize, it is easier, right? So we have this now, x squared minus x, then we have plus 1. So here now, we'll group them into twos. These two will group them together, these two will group them together. That's why we needed to have 4, so we can group them 2. So now from each bracket, we'll check what is common between them. Here we have x is common, so we'll bring x out. Then what do we have left here? We have x, because x times x will give us x squared. Then here we have minus 1. X times x, x squared, x times minus 1, x, right? Minus x. So this means that this is correct. So for this one now, we have minus x and plus 1. How can we factorize this? What is common between them? Basically, minus 1 is common, right? We can bring out minus 1. So if we bring out minus 1 here, minus x divided by minus 1, the minus will cancel out minus, so we have x, right? Minus 1 times x will give us minus x, right? So for this one now, minus 1, we have 1 divided by minus 1, that will give us minus 1. Minus 1 times minus 1, minus times minus will give us plus 1 times 1, 1. So then this is correct. So now, since these two brackets are the same, these two brackets must always be the same. Once they're the same, then you know you are correct. So for this one now, this place is, so for this one now, you're going to be having x minus 1, and you're going to have x minus 1, right? You're having something like this, x minus 1 and x minus 1. Okay, x minus 1 and x minus 1, and then you can plug it in into the this way. Now you have factorized this, because if you multiply this out, you should be getting x squared minus 2x plus 1. So x times x will give you x squared, x times minus 1 will give you minus x, x times minus 1 times x will give you minus x, minus x times minus plus minus x will give you minus 2x. And we have minus 1 times minus 1, which will give you plus 1. So it means that this is correct. So let's plug it in here. So we have x minus 1, x minus 1 over x plus 1. I think this should be a mistake in the question. I think this was meant to be x minus 1, right? It's supposed to be x minus 1, then we'll be able to cancel out. So let me just do that quickly. Let me change this. Okay, so we have x minus 1 here. So this one will cancel out this one. So what we have left is x minus 1. So here we are now, it's very basic. So we're having limit x to minus 1. So here we're going to have minus 1, and this is going to be minus 2. Very, very simple. And we have gotten our answer that way. So that's this one. Everything we did here from question 3 to question 5 is limits by factorization. Now let's use L'Hopital's rule. Let's use L'Hopital's rule. Now for L'Hopital's rule, there are some conditions that have to be met. The condition that has to be met is that when you put the values that are limiting to into the expression, you are supposed, if you get 0 over 0, then you use L'Hopital's rule, right? So something like this. Now for question 3, you have limit x to 2, and the expression is x squared minus 4 over x minus 2. Now whenever you carry limit x to 2, whenever you take 2 and you just put it inside, right, as if you are substituting. Remember, whenever you have something like this that is not as simple as that 2x plus 5, you have to use substitution, factorization method, or use this L'Hopital's rule. But L'Hopital's rule has a condition, right? But to know the condition, to know whether it meets the condition, you just take this 2 and just put it into as x, right? So putting it as x, we have 2 raised to power 2 minus 4 over 2 minus 2. 2 raised to power 2 is 4. 4 minus 4 over 2 minus 2. This will give us 0 over 0. Whenever you put the limits, what you are limiting, into the expression, and you get 0 over 0, you can use L'Hopital's rule, right? This is not your answer, But whenever you put 2 and you get 0 over 0, you can use L'Hopital's rule. That's basically what L'Hopital's rule is. So now, what is L'Hopital's rule and how do we use it? For L'Hopital's rule, what you are going to do is that first, you check whether it gives you 0 over 0. Then second, you are going to find the derivative of the numerator. And the third, you're going to find the derivative of the denominator. And then for the fourth step, you are going to limit by substitution, right? So now, whenever you have something like this, x over y, this one up here is your numerator, and the one down is your denominator, right? So basically L'Hopital's rule is telling us that after it has checked this box 0 over 0, then you differentiate what is up, you differentiate what is down, then what you are left with you limit by substitution, and you get your answer. So let's do it for question 3, 4, 5. Remember the answers that we got I think we got 4 for question 3, 6 for question 4, right? So let's try it and let's see if we are going to get those same answers using L'Hopital's rule. First we have to check if it follows the rule. If it does not follow the rule, then we just use limit by factorization. Okay, so now for question 3 we have limit x to 2. We have already checked already and we saw that it gave us 0 over 0, so we're going to just differentiate. So differentiating x squared minus 4, if you don't know how to differentiate, please go and watch the video on differentiation before you come and continue with this. So now we have x squared, so this is going to give us 2x over 1, right? 2x over 1, because 4 is a constant, it does not have x. When you differentiate it with respect to x, it automatically becomes 0. Same thing here, for this x it becomes 1, so we have 2x, right? So from here now we have differentiated the numerator and we differentiated the denominator. So what is left now is step 4, which is to impute your 2, which is the limit by substitution. So x limited to 2, so we have 2 into the bracket of 2, and here we have 4. The same answer that we got, right? So you can use any of them that you feel that you want to use, because it's CBT, right? So use any one that you want to use, but just check, does it follow the rule? Does it check the box? Does it give you 0 over 0 before you can use L'Hopital's rule? So now let us deal with question 4. So for question 4, here we have limit x to 3. So here we have x squared minus 9 over x minus 3. Let's check if it follows, right? So let's put 3. So we have 3 squared minus 9 over 3 minus 3. 3 squared is what? 9. 9 minus 9 is 0. 3 minus 3 is 0. So it follows L'Hopital's rule. So let's solve. So we're going to differentiate the numerator. So that will be 2x. Now differentiate the denominator. That will be 1. So we have 2x again. So put our 3. So we have 3 here. Limiting by substitution, and this is 6. The same exact answer. So now let's do for the last one. Let's see, question 5. Can we use L'Hopital's rule? So for number 5, we have limit x to minus 1. We have x squared minus 2x plus 1, and then we have over x. I said this was supposed to be x plus 1. X plus 1. Let's go. So now here we are putting minus 1. So when we put in minus 1 for this one, so we have minus 1 squared, which is just going to be 1. Then we have minus 1 times 2. Minus 1 times minus 2, that will give us plus 2. Then we have plus 1. But for the bottom, we have minus 1 plus 1, which will give us 0. And this is going to give us 2 plus 1, 3 plus 4. That's 4 over 0. So that means this does not follow L'Hopital's rule, and then we cannot use that method for this question. So basically this is the entire breakdown when you use L'Hopital's rule, when you use limit by factorization. So you should be able to be good with this. Now, not everything, right? It's not everything that is factorizable. Let's say you have something like this: x raised to the power 3 minus 7x squared plus 5x minus 4. You cannot factorize something like this, right? So when you cannot factorize something like this, you check. Most times you are able to use L'Hopital's rule, right? So if you check and it does not also follow L'Hopital's rule, you cannot factorize. You cannot use L'Hopital's rule. You're just going to use limit by substitution. When you cannot factorize, you cannot use L'Hopital's rule, you use limit by substitution, and then you get your answer. So let me just use this video to explain limit to infinity, so I don't have to make another video. So limit to infinity. So let's say for question 1 now, we have x, we are limiting to infinity, and we have 2x plus 5. What you are going to do is that you are going to divide through by your value of x, right? By the highest degree of x in this expression. The highest degree of x here is 1. So I'm just going to say 2x over x plus 5 over x, and then this is going to be x will cancel x, so you have 2 plus 5 over x. So now here you are going to limit to infinity. So you are limiting to infinity here. So you're going to basically you're limiting by substitution, because you're just going to put your infinity as x, right? Now whenever we have anything over infinity, it's automatically equal to 0. So this will be 2 plus 0, and this will give us 2 if you are limiting to infinity. Alright, so now let's try for question 2. For question 2 now, okay. So for question 2 we have limit x to infinity. We are doing infinity now. So that's x plus 3 over x minus 2, and this will give us x over x plus 3 over x plus x over x minus 2 over x. So here we're having 1 plus 3 over x over 1 minus 2 over x. So we're going to limit x to infinity now. So we have 1 plus 3 over infinity over 1 minus 2 over infinity. This will give us 1 plus 0 over 1 minus 0. This is basically 1. So limit to infinity, there is nothing there. Let me just take one more example on limit to infinity. I'm using question 5 because that one seems the most complex. So let's go. Question 5 now. We have x squared minus 2x plus 1 over x plus 1. So here we're limiting to infinity as well. Limiting x to infinity. So what we're going to do, we're going to divide by the highest degree of x. In this case, it is x squared, not just x. So we're having x squared over x squared minus 2x over x squared plus 1 over x squared. Please do not forget. But for the denominator, the highest degree is just x. So we're going to divide by x plus 1 over x. So here, this will cancel this. So we have 1 minus x here will cancel x here. So we have just x left. So minus 2 over x plus 1 over x squared over 1 plus 1 over x. So we're limiting to infinity. So let's substitute. So we have 1 minus 2 over infinity plus 1 over infinity squared over 1 plus 1 over infinity. Whether it's infinity squared though, infinity is over 100 though, whenever the infinity is under, it is automatically equal to 0. So we have 1 minus 0 plus 0 over 1, right? And this is equal to 1 as well. So it's very, very simple stuff. Very, very simple. You just get this concept and then you're good to go.